Hi guys, welcome to the module on operators and expression. In last few modules, we have learnt how to install and work with Python. What will you learn in this module? As you have completed the module on literals and strings, you should be able to create Python objects of different types. Now, you are going to hear about the types of operators and how to use them for building expressions. By the end of this module, you will be able to create simple and complex expressions by using objects and operators. Okay. First, let us start with type of operators. What is an operator? Operators are special symbols in Python that perform some operations like arithmetic or logical operations, etc. The value that the operator operates on is called an operand. For example, consider A plus B. Here, plus is the operator and A and B are the operands, right? Let us now look into the types of operators supported by Python. They are arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, identity operators and membership operators. Shall we have a look on these operators one by one? Yes. Okay. First, let us see about arithmetic operators. What are the arithmetic operators? Arithmetic operators are used to perform mathematical operations like addition, subtraction, division, multiplication, etc. Hope you already know these operators. Have a look on the screen for the arithmetic operators in Python. Here what you are seeing is the list of arithmetic operators available in Python. So, plus is used for adding two operands, minus for subtracting two operands, star for multiplication, slash for division, percentage which is also called as modulus operator used to find the remainder of division of the left operand by right operand, and Python has one special arithmetic operator called double slash which is used to perform floor division. As you can see, when you perform floor division of 9 by 5, actual answer would be 1.4, but because it is floor division you are getting 1. Similarly, you can see other examples too, and double star is used to perform the exponentiation operator. Let us now try a small example illustrating how to use these arithmetic operators. Please go to your Python IDLE and type as you are seeing now. This example illustrates the various arithmetic operators. As you can see, we are adding two numbers, say number 1 and number 2, and printing the result, and subtracting, multiplication, division, and again we are performing floor division and exponentiation. When you run this program, you get the output as shown now. You can see here the output of the program just now we wrote. Please check the output with the output what you are getting. The arithmetic operators are binary operators. This means that they all require two operands each on either side of the operators. In addition to this, plus and minus can also be used as unary operators, that is with one operand. they are used for indicating the sign of the operand. The expression which we form using arithmetic operators are known as arithmetic expression. Towards the end of this module, we will discuss about expressions. Next, we will move on to the relational operators. Relational operators are used to compare the values of the operands on either side of them and decide the relation between them. They are also called comparison operators. What you see here is the list of comparison or conditional operators available in Python, which are double equal to, not equal to, greater than equal to, less than equal to. So, I do not need to explain. From the slide itself you can understand how to use these operators. Shall we see an example script which illustrates the use of comparison operators? Yes, move on to the Python IDLE and try the code on the screen and also verify the output. This example demonstrates how to use the relational operators just now we saw. And as I told you, the output of the relational operator will be either true or false. So, try these example by yourself and see the output. Here what you see is the output of the previous program which we have written using comparison operator. As I told you, the output of these operators will be either true or false. Note that the result of applying these operators are Boolean values, that is true or false, and the expression written using relational operators are called as relational expressions. Can you say whether the relational operators are unary or binary? Yes, as you have guessed, they are all binary operators. Okay. What is the next type of operators? Next is logical operators. These operators are used to combine the conditions which use the relational operators for comparison. That is, to combine the relational expressions, we use logical operators. They include and, or, and not. Watch the meaning of these operators over the screen. What you see here is the logical operators available in Python, which are and, or, not. Coming to and, if both the operands are true, then the and operator returns true, otherwise false. Please see the example A and B, A less than B and A greater than B. This is how you can use AND operator. Coming to OR, if any one of the operand is true, then OR returns true, otherwise it returns false. You can see how to use OR operator also. Next comes NOT operator. NOT operator is to change the result of the operand, that is true if the operand is false or false if the operand is true. Please note how to use this operator. Now, shall we try an example for these operators? What you see here is an example program for using logical operator, and it illustrates how to use the AND or NOT operator. Considering an example where A is equal to 10, B is equal to 5 and C is equal to 15. Suppose if I compare A less than B and A less than C, what would be the answer? Or if I compare A less than B or A less than C, what could be the answer? So, here you see the output for the previous program which was written using logical operator. So, for A less than B and A less than C, the answer is false, because A is not lesser than both, but A less than B or A less than C is true, because A is lesser than B, but it is greater than C. So, you have true answer. Note down that the logical and logical OR are binary operators and logical NOT is an unary operator. What is next? The next type is bitwise operators. Bitwise operators works on bits and performs bit by bit operation. The bitwise operators in Python can be seen on the console. Here you can find the list of bitwise operators supported in Python. They are bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, bitwise right shift, bitwise left shift. Also note how to write these operators in Python, and example can also be seen on the console. Let us see how to work with these operators and also note how these operators work on individual bits. What you see here is the working of bitwise operator. So, coming to bitwise AND, if any one of the input is 0, then output will be 0 for bitwise AND. So, for example, if R1 is 0 and R2 is 0, then R1 and R2 will be 0. Similarly, if R1 is 0, but R2 is 1, but again R1 and R2 will be 0. Coming to bitwise OR, if any of the input is 1, then output will be 1. So, if R1 and R2 are both 0, output of R1 or R2 will be 0, but if any one of the input, say for example, R1 is 0 and R2 is 1, then the output will be 1. Then coming to exclusive OR, if all the inputs are same, then output will be 0. So, both R1 and R2 are 0, then exclusive OR operation R1 or R2 will be 0, but coming to R1 is 0 and R2 is 1, exclusive OR of R1 and R2 will be 1. So, this is illustrated again with an example. For example, A is equal to 5, if it is written in binary, it is 0 1 0 1, and B is equal to 7, written in binary, it is 0 1 1. When you perform AND operation, the answer will be 0 1 0 1. So, you can use the above table to calculate this logical bitwise OR. Then coming to OR operation, again it is shown on the screen, but the result of OR operation is 0 1 1. Let us now work in Python to understand these operators further. So, what you see here is the working of exclusive OR. So, when you do exclusive OR on A and B, you get answer as 0 0 1 0. So, you can use the table which I explained just now to understand how did you get this result. Then coming to right shift, A right shift 1. For example, if A is 5 0 1 0 1, right shift by 1. So, here the operand 0 1 0 1 is moved right by the number of bits specified by the right operand, that is shift right by pushing the leftmost bits from the left and let the rightmost bits fall off and insert 0 at the leftmost position. So, when you do right shift on A, you will get 0 0 1 0, that is 2. What you see here is the left shift operator. As we have done for right shift, here A is shift left by 1 position. So, if A is 5, when you shift it left, the result will be 1 0 1 0, that is 10. Then the last bitwise operator is complement operator, which inverts all 1s to 0 and vice versa. If A is 10, then complement of A is minus 6. So, here we are presenting an example to understand how to work with bitwise operator. Please run and see how the output is. Here you see is the output for the previously written script on bitwise operator. Here apart from bitwise NOT, which is an unary operator, all are binary operators. Did you notice the output of bitwise NOT? Why is it in negative? The bitwise complement of 5 is minus 6 instead of 10. For an integer operand, bitwise complement of it will be minus n plus 1. But why? This is because in integer numbers, the leftmost bit is used for determining the sign of the number, that is negative or positive. So, when we apply bitwise NOT in binary, the leftmost digit of 5 is 0. This 0 is reversed to 1, which changes the sign of the number from positive to negative. To find the inverse number, take 2's complement of the other digits. This can be noticed on the screen. Complement of 5 is minus 6. How? 5 in binary is 0, 1, 0, 1. But complement of 5 is 1, 0, 1, 0. Here the leftmost bit indicates it is a negative number as it is 1. Then take 2's complement of the remaining digit. The remaining digit of 5 is 101. In order to take the 2's complement, first find that 1's complement and add 1 to it. So, 1's complement of 101 is 010. When you add 1 to it, you will get 110. So, complement of 5 is minus 6. So, here we have presented to you the list of bitwise operators that are available in Python. Got it? Okay. Python has certain assignment operators which are used to assign values to variables. The first one is assignment, that is equal to. X is equal to 12 is an expression which assigns the value of 12 on the right to the variable x on the left side. The other assignment operators are compound operators like plus is equal to, minus is equal to, etc. For instance, x plus is equal to 12 adds 12 to the present value of the variable and assign the result to the variable x, which is equivalent to x is equal to x plus 12. Python has several such operators as you can see now. What you see here is the list of assignment operators available in Python. The working of these assignment operators are similar to the operators like arithmetic operators and bitwise operators what we have just now saw. This slide also shows you how to use these operators. Let us have a program to understand this. Let us work out an example for understanding the usage of assignment operators. Students, please see the program to illustrate how to use arithmetic and other type of assignment operators. You can try with other assignment operators too. Here only 4 operators are shown. The output of this program is shown on the monitor. For the previously shown program, this is the output. You try by yourself. I suppose that you have understood all the operators which we have seen so far, and these operators are also available in many programming languages like C, C++, Java, etc. There are some special operators that are exclusive for Python, which are identity and membership operators. Let us have a look on them. The identity operators are is and is not. Identity operators compare the memory locations of two objects. That is, they check if two values are located on the same part of the memory. Two variables that are equal does not mean that they are identical. See the way of using these operators. So, this is the program which illustrates the use of identity operators in Python. Is and is not is the identity operator in Python. Suppose A is equal to 5 and B is equal to 5. We are just checking A is 5, because as I told you already, everything is object in Python. So, both A and B have the same value, that is they refer to same object. So, if I give A is B, then I will be getting the answer as true. Suppose if we change B is equal to 51, then when we check A is B, what will be the answer? Try by yourself. Again I change the value of B to 5. Now check what would be the answer. Okay. Suppose I have a list x is equal to 1, 2, 3, 4, 5 and another list y which is also having the same value 1, 2, 3, 4, 5. I am trying with two operator, one with is which is an identity operator and other one is equal to, that is the relational operator. Do you think that you will get the same answer for this? What would be the answer for is operator and what would be the answer for equal to operator? Is operator will check for the object memory and double equal to will check for the values. Now see the result of using identity operators. So here for the first A is B we got true and second is we got false as the answer and third one we got true, and when we check is with the list they refer to different location. So, I have false as the answer, and when I use double equal to which says the contents are equal. So, I am getting the answer as true. So, here note that even if list x and y have the same values, since lists are mutable objects, the contents of the two lists are stored in separate memory locations, but the content wise they are equal. That is why we got true when we have used double equal to operator. Please do remember that every object in Python has its own memory space. Next type of special operator in membership operator. In and not in are the membership operators in Python. They are used to check whether a value or variable is found in a sequence such as string, list, tuple, set and dictionary. Note that in a dictionary we can test for existence of a key only, not the value. Already we gave a brief overview of list, tuple and dictionary in one of our earlier modules. Let us see about them in detail in forthcoming modules. Shall we try an example for membership operators? Here we see is the list of membership operators in Python which are in and not in. So, this example illustrates the usage of these operators. Suppose x is a string having Python programming as its value and y is the dictionary. We will see in later modules how to create dictionaries. Now, we are checking for whether capital P is in x. Is it not present? Yes, it is present. So, we will get true as the answer. Next, we are checking whether the Python string is present in x. Is it present or not? Yes, it is present. So, you will be getting true as the answer. What we are checking next is Python not in X. Is Python not in X? No, it is present in X. So, I will be getting the false as the answer. Then coming to the next one, Y in Y. Y is the list, Y is the dictionary having key value pair. So, there is a key called 1 is present. So, Y will be having the keys 1 and 2. 1 in Y will be true because 1 is present. Coming to the last statement, A in Y. So, this is not possible because you cannot check for the presence of values in the dictionary. You can only check for the existence of keys. So, let us see what is the output we are getting for this program and see the results now. So, this shows the output of the previously written program on membership operators. Again, remember that both identity and membership operators are binary operators. Having seen the different types of operators along with example, it is time to dwell into expressions. What is an expression? An expression is a combination of literals, variables, operators and calls to functions. An expression needs to be evaluated. The evaluation of an expression results in a value. The expression to be evaluated appears on the right hand side of the assignment operator. A value or a variable all by itself on the right hand side is a simple expression. For example, b equal to 0, a equal to b are all simple expressions, and a is equal to 10 plus 2 into 3 is also an expression. In our previous expression, that is in 10 plus 2 into 3, we have two operators which are plus and star. Here I have a question for you. Which of these two operators will be executed first? Either plus or star? Here comes the precedence and associativity. In the remaining part of this module, you will learn about Python operators, precedence and associativity. After reading it, you should be able to know how Python evaluates an expression based on their precedence and associativity. Some operators have higher precedence than others. So, let us have a peep into them. Python interpreter evaluates the expression by performing the operations with the operators whose precedence is high compared to other operators, and except the exponent operator, that is double star, all operators are evaluated from left to right. So, let us first see the precedence of the operators and work out a few examples. So, here we show the order of precedence of the operators present in Python. So, this order illustrates the order in which the expressions have to be evaluated starting from 1 to 4. So, when you have an expression having multiple operators, then you can evaluate the operators based on this table. So, this example illustrates the use of precedence table and how can we change the order of evaluation. So, as you notice in this example, A cross B plus D by C, how this gets evaluated? Here we have star, plus and slash. Star and slash have higher precedence compared to plus, and they are all left to right associativity. So, star is performed first, then division is performed, then these two results get added. Suppose you want to perform plus first, then you have to put bracket as it is shown here. And similarly, consider the example of A double star 3 double star 2, and this exponential operator will follow the associativity of evaluation from right to left. So, this is evaluated as follows. First 3 part 2 will be evaluated, that will be used to calculate the power, that is A power 9 is calculated next. Suppose you want to do A power 3 first, then power 2, then you have to put a bracket. As I just now told, if you want to perform A power 3 first, you need to put parenthesis, because this operator follows right to left associativity. And I have shown some more example, you just work those example and see what would be the answer. You can see from the precedence table that more than one operator have the same precedence. When two operators have the same precedence occur in an expression, associativity helps to determine which is the order of operations. Therefore, associativity is the order in which an expression is evaluated that has multiple operators with same precedence. All the operators except double star, that is the exponentiation operator, have left to right associativity. Exponentiation operator has right to left associativity. In one of our earlier expression, that is 10 plus 2 into 3, we have two operators which are plus and star. We had a doubt on which of these two operators will get executed first, either plus or star. But now you can say that star is done first as it comes before plus in the precedence table. You may try a few examples of your own for practice. Let me now enumerate the rules to be followed while evaluating an expression. To remember the rules, keep in your mind the word PEMDAS. So, when you have a confusion of how to evaluate the expression, when the expressions involve multiple operators, you can follow this PEMDAS rule, where P stands for parenthesis, E for exponentiation, M for multiplication, D for division, A for addition, S for subtraction. Parenthesis as the highest precedence. It can be used to change the order of evaluation of an expression, that is, you can evaluate in the order you want. We have already seen example for this case. Next comes function. We will see how to work with function in a later module. Exponentiation as the highest precedence, this was also shown. Operators with same precedence are evaluated from left to right except double star, that is exponentiation. So, when there is a confusion about the evaluation of an expression, always put parenthesis in the expression to make sure that the computations are performed as you like. To summarize, in this module, you have learnt about the various operators that Python supports to combine the objects into expressions. The operators, operands and expressions are the basic building blocks of any program. Hope you have got a clear view of operators and expressions. In the next module, we will be discussing on input and output statements of Python. Have a good day. Thank you.